So welcome you to this another session on convolution sum examples. In this session, we are solving convolution between two exponential signals which are infinite duration. And another example that I have taken is to obtain the step response of a signal. So two examples I am taking in this session. So first let us concentrate on obtaining the convolution between two exponential signals which are infinite duration. So here I have considered it as hn is equal to alpha raised to n un and xn is equal to beta raised to n u of n minus 2. So my assumption here is that alpha and beta both are less than 1. Now, if alpha and beta are less than 1, then what should be the nature of exponential that we are going to sketch? And how it exists? If hn is alpha raised to n un and xn is beta raised to n u of n minus 2, what is its existence? That is, from what value of n they start and with what value of n that they end. So, for xn, if you observe, its amplitude is beta raised to n and the product with u of n minus 2 represent that it exists from n is equal to 2 to infinity. So sketching this xn with beta raised to amplitude of beta raised to n. So assume that beta is less than 1. So if beta is less than 1, the exponential will be, what is the nature of exponential? So it is a decaying exponential. So beta is less than 1. So if is the amplitude, if you go on sketching with the power of n as it goes on increasing, the amplitude will go on decreasing. So it is a decaying exponential. So let us sketch this xn, which is beta raised to n. So it is a decaying exponential. So this is beta raised to 2, this is beta raised to 3, beta raised to 4, beta raised to 5, beta raised to 6 and so on. This will go on gradually decaying, and as it goes towards infinity, it will be tending towards 0. So this is the nature of xn, and it is existing from n is equal to 2 onwards up to infinity. Now what is hn? Since alpha is also assumed, it is its amplitude is alpha is less than 1, it is a decaying exponential and is starting from n is equal to 0 onwards. So alpha raised to 0, alpha raised to 1, 2, 3, 4, so on up to infinity. It will be decaying towards 0. So it is also a decaying exponential, alpha raised to n. So after sketching this xn and hn, what is our next step is to identify the left end of yn and the right end of yn. Now if you have gone through the previous example and the previous slides, I hope that you will be in a position to write what is the left end of yn and what is the right end of yn. So what are that? So the left end of yn is the left end of xn plus the left end of hn. So left end of xn is 2 and that of hn is 0. So the left end of yn is 2 and the right end of yn is, both these are infinite duration. So right end is infinity. So now being known this left end and right end, our next step is to reflect h of n about the origin and then redesignate it as h of minus k and extend to redesignate it as xk. So we sketch xk and hk because in convolution we need to take a product between xk and h of n minus k, where h of n minus k we obtain by shifting left of right h of minus k depending upon the value of n. So this is h of minus k. Now on depending upon the value of n, if n is less than 0, we are supposed to shift left this h of minus k, and if n is greater than 0, we are supposed to shift right this h of minus k, and we are supposed to take the product between the xk and h of n minus k, add all the samples of the product signal and obtain yn at that instant. Now if you observe here, in this case n is equal to 0. Now if I multiply this xk and h of minus k to obtain y at 0, you observe here that there is no overlapping of samples of xk and this h of minus k. So definitely the product is equal to 0. So then another observation here is that there is no point of shifting left this h of minus k, because if you shift left also, there will not be any overlap between xk and the shifted h of minus k. So the product definitely will be equal to 0. So there is no point of shifting left and obtaining the values for n which are less than 0. Even since we have already obtained the left hand of yn, let us start from n is equal to 2, because you can observe here easily that even up to 1 there will be no overlapping between xk and h of 1 minus k, and the product will be equal to 0. And if you shift right this h of minus k by amount of 2 to obtain h of 2 minus k, and if you resketch this h of 2 minus k, what is your observation? So for n less than 2, x of k into h of n minus k is equal to 0. And now for n which is greater than 2, the overlap starts. The overlap of this sample starts. For less than 2, there will be no overlapping between this xk and this h of n minus k if n is less than 2. So the product is xk into h of n minus k will be equal to 0. Now onwards the product will start, that is from n is equal to 2 onwards. So the product now exists for n is equal to, so not n, it is k. So the product exists for k is equal to 2 when n is equal to 2. So this is n and this variable is k. So see here, these expression of convolution sum, that is yn is equal to summation k from minus infinity to plus infinity x of k into h of n minus k. So this xk into h of n minus k is equal to 0 for n less than 2. Therefore this yn will be equal to 0, because the sum will be equal to 0, because since product is 0, the sum also will be equal to 0. Now for 2, the overlapping is there for 2. So the product will exist from 2 to 2. And then we write this expression for y2 is equal to k varying from 2 to 2 xk into h of 2 minus k. So when it comes n is equal to 3, then we are supposed to shift this h of 2 minus k to the right side by one more times. So if one more times if you shift this to obtain h of 3 minus k, you will observe that this xk and this h of 3 minus k, now they will overlap for this 2 duration, that is from 2 and 3, for this 2 duration. And then at that time this summation will be varying from k varying from 2 to 3. And if I go on like this, shifting this h of n minus k towards the right side, every time I shift, what is your observation? Now this is infinite duration signal and it is existing up to minus infinity. So I'll be going on shifting to the right side infinite times. So every times if I shift this h of n minus k to the right side, our observation that the overlapping always starts from the lower end or the left end of the product starts from 2. What is the right end? So for n is equal to 2, the right end will be 2. If n is equal to 3, the right end will be 3. If n is equal to 4, the right end will be 4. If n is equal to, in general, h of n minus k, then the right end will be what? The right end will be n. So see here, observe, this is shifted by an amount of n, and you observe here that always the overlapping will exist from 2 to n. How many times you have shifted right, that many times this 2 will overlap to each other and the product will exist from 2 to n. Therefore, the convolution sum expression becomes summation k from 2 to n xk into h of n minus k. Now, if you observe here, what is the amplitude of xk and what is the amplitude of h of n minus k? Xk is beta raised to k and h of n minus k is alpha raised to n minus k. Therefore, yn is equal to summation k from 2 to n beta raised to k into alpha raised to n minus k. Now, if I split this alpha raised to n minus k, you can Observe here that alpha raised to n is not a variable of k, that is summation which is varying with respect to k. So we take it outside the summation alpha raised to n. So inside the summation we remain with beta raised to k into alpha raised to minus k. Now this beta raised to k into alpha raised to minus k can be written as beta by alpha raised to k. Now what is the closed form expression of this? The lower limit is 2, the upper limit is n. This alpha raised to n is constant, you keep it as it is. What is the closed form of expression? What is the summation value of this? So it is beta by alpha raised to 2 minus beta by alpha raised to n plus 1 upon 1 minus beta by alpha. So this summation exists for n which is greater than or equal to 2. For n less than 2, we observe that this yn is equal to 0. For every value of n which is greater than or equal to 2, this is alpha raised to n into 1 minus beta by alpha raised to n plus 1 upon 1 minus beta by alpha. I can also modify this by multiplying. So previous, see here, this is alpha raised to n. Now what I will do is, I'll take common here 1 by alpha. So multiply here numerator and denominator by alpha. So this alpha will become alpha raised to n plus 1, and therefore here you will get in the denominator alpha minus beta. So this alpha raised to n plus 1, when you multiply inside here to this numerator, you will get alpha raised to n plus 1 minus beta raised to n plus 1 upon alpha minus beta. So this is for n which is greater than or equal to 2. So if you want, you can also write this as yn is equal to alpha raised to n plus 1 minus beta raised to n plus 1 upon alpha minus beta into u of n minus 2. In terms of unit step function also you can write yn. That is optional. Okay. Now this is the second example where we are supposed to obtain the step response of the signal if step response if hn is equal to 1 by 2 raised to n u of n minus 2 of a system, step response of a system. If hn is 1 by 2 raised to n u of n minus 2, whereas the impulse response is 1 by 2 raised to n u of n minus 2. Now the meaning of obtaining a step response is the output to the step input that we are supposed to find. That is, we have to assume xn which is equal to un and obtain yn, that is nothing but the step response. So we sketch xn which is a step signal and this hn which is given as half raised to n u of n minus 2. So it starts existing from n is equal to 2 onwards up to infinity, and the amplitude is 1 by 2 raised to n. So this is a similar kind of example which already just now we have discussed. So only thing is that here this is a unit step function, x of n is a unit step function and the other one is a exponential signal. Now the left end, if you see, is equal to 2 and the right end is equal to infinity. So we shall start it by sketching xk and h of minus k, and then to evaluate the convolution, as there will be no overlapping up to n is equal to 2, we shall shift this h of minus k 2 times here towards the right side and straight away start for n is equal to 2 onwards, because then for n less than 2 there will be no overlap between xk and h of n minus k, therefore the product will be equal to 0, and then definitely yn also will be equal to 0. So for n is equal to 2, we shift right this h of minus k by 2 and obtain this h of 2 minus k. Now we observe here that for n less than 2 our product is 0, and for n is equal to 2 the product exists at only k is equal to 0. So the overlap is for the sample at k is equal to 0. So the product exists at only k is equal to 0. So the summation becomes varying from 0 to 0 xk into h of 2 minus k. This was supposed to be. This is not, to remodify this. This is not minus k, this is 2 minus k, h of 2 minus k, okay. I hope you understand. So this is h of 2 minus k, and the product exists from 0 to 0. Now onwards there, that is for n which is greater than 2, we further go on shifting right this h of n minus k. And what is your observation? So for n is equal to 2, the product is existing from 0 to 0. For n is equal to 3, the product exists from, so left hand is 0 and it will exist up to 1. So for, what is your observation in general for n? What is left? Left hand is always 0. What is the right hand? If I shift n times this h of n towards the right side, so what is this end is? This is nothing but n minus 2, right or not? So this end is n minus 2 if you in general shift h of n towards the right side by an amount of n. So then this will be existing up to n minus 2, and the product will overlap for the samples varying from 0 to n minus 2. Therefore, we shall write this convolution expression as summation k varying from 0 to n minus 2 xk into h of n minus k. Now, what are the amplitudes of xk and h of n minus k? Xk is 1 and h of n minus k is half raised to n minus k. So, substituting that in the expression of convolution here, we get yn is equal to summation k from 0 to n minus 2 into 1 by 2 raised to n minus k. Now, taking outside 1 by 2 raised to n of this summation variation, 1 by 2 raised to n, and this is summation k varying from 0 to n minus 2, 1 by 2 raised to minus k this should be, and this 1 by 2 raised to minus k shall be written as 2 raised to k. So let me modify here, this is minus k, right? And this 1 by 2 raised to minus k shall be changed to 2 raised to k. Now what is the expression, this evaluation of this summation which is varying from 0 to n minus 2? So let us write that, the closed form expression of that, 1 by 2 raised to n, 1 minus 2 raised to n minus 2 upon 1 minus 2. Now 1 minus 2 is minus 1. So I will modify this numerator as 2 raised to n minus 1 minus 1. So 2 raised to n minus 1 minus 1. Yn is equal to 1 by 2 raised to n inside the bracket 2 raised to n minus 1. Now what can be done ahead? Can you guess? We shall multiply inside with this half raised to n. So when you multiply here, this 1 by 2 is, you keep one aside, here you have 2 raised to n minus 1. So if you multiply here inside, this is 1 and this is minus 1 by 2 raised to n minus 1. This is for n which is greater than or equal to 2, and yn is equal to 0 for n which is less than 2. This can also be written as, this is yn is equal to 1 by 2 minus 1 by 2 raised to n into u of n minus 2. This is in terms of a step function. Now this yn can be redesignated as Sn because this is a step response. This output yn is obtained with the step input. So this yn can be redesignated as a Sn, but it is asked to obtain a step response. So you can redesignate it as Sn. So this is an exercise for you to obtain yn if hn is alpha raised to n u of n minus 3 being a which is less than 1 and xn is equal to un. So I hope that you will do it for yourself by going through this example which I have solved. So thank you very much for your patience hearing, students.